The next thing that we need to talk about is what makes something statistically significant and what are the two possible conclusions for our significance test. Okay, there are two possible conclusions. If our probability is small enough, that means our results are statistically significant and we are going to reject the null. Okay, if our results are not statistically significant, meaning that we don't have a probability low enough, then we are going to fail to reject the null. Some of the biggest mistakes that you could ever make, or one of the biggest mistakes you could ever make, is to accept the null. You kind of have to think about it in terms of a jury trial. Okay? When jurors have decisions to make, they always either decide or they always either come back and say guilty or not guilty. They never come back and say guilty or innocent. It's kind of the same thing here. We can't come back and say that our null is true. That would be like saying innocent. Because it may be that sampling variability, we have no proof that the exact null is true. We just have proof that we cannot reject it. So that maybe our alternative is not true. So we have to say reject or fail to reject, even though I wrote accept because I was trying to tell you not to accept. That's the biggest mistake that students make, is that they actually say accept the null. Do not say accept. Okay, also always make sure that you talk about either rejecting or failing to reject the null in context. Okay, a significance level is kind of the boundary level. The boundary that we use to decide, yes, I'm going to reject the null, or I'm going to fail to reject the null. Symbolically, we refer to that significance level as alpha. Okay, the Greek letter A. Okay, so the results of a study are statistically significant, and that's when we're going to reject the null. When our p-value that we talked about yesterday is less than alpha. Okay, we are going to fail to reject, meaning our results are not statistically significant when our p-value is greater than alpha. So less than alpha, reject. Greater than alpha, fail to reject. Okay, so for his second semester project in AP Statistics, Zenon decided to investigate whether students at his school prefer name brand potato chips to generic potato chips. So he randomly selected 50 students and had each student try both types of chips in random order. Overall, 34 of the 50 students preferred the name brand potato chips. So Zenon performed a significance test with the hypotheses the null is p equals 0.5 and the alternative is p is greater than 0.5, where p is the true proportion of students at his school who preferred the name brand potato chips. So the resulting p-value was 0.0055. What conclusion would you make at each of the following significance levels? So, what conclusion would we make at each of the following significance levels? Alpha is 0.01. Okay, when alpha is 0.01, notice that our p-value is less than alpha. Okay, that means our results are statistically significant, and what we would say here is we would reject the null hypothesis. Okay, so I would reject the null because the p-value is less than alpha. And then I would say in a complete sentence with context these words. We have convincing evidence. There is convincing evidence to say that students at Zenon School prefer name brand potato chips. Okay, over here, alpha is 0.001, which means the p-value is greater than alpha. That means I would fail to reject the null. And then I would say these words in context. There is not convincing evidence that students at Zenon School prefer name brand potato chips. Notice the only difference in the two context sentences is for this one we say there is convincing evidence, and for this one we say there is not convincing evidence. Then what we have to do is always say it in context. And don't forget, you need to compare the p-value and alpha when deciding to reject or to fail to reject. Okay, things that should be considered when choosing a significance level are many things. One, how plausible is your null hypothesis? Okay, the more that people believe the null, the more evidence they're going to need you to show them that the null is incorrect. So you need to pick a smaller significance level. Also, you want to consider, well, what kind of consequences do I have for rejecting the null? If your consequences for rejecting the null, say like if you're in medicine and you need to, do more research or do something that's going to cost you a lot of money or redo a medicine, you're going to want to make sure you use a smaller significance level so that you can be sure that if you're going to spend all the money or spend all the time, that it's for a good reason and not because your significance level was so high, like 0.1 or 0.5 or 0.2, that you rejected the null when you really shouldn't have. That leads us to our next discussion, which is about the type of errors that we can have. I've mentioned several times that we need to pretend like we're juries or we're lawyers. And in a jury trial, there are two types of errors a jury can make. One, they can say the person is not guilty when they really are guilty. Or two, they can say the person is guilty when really they were not guilty. We can make those same two errors in a significance test. Okay? In a significance test, the first error we can make is that we can reject the null when it really was true and we should not have rejected the null. Okay? This is called a type 1 error. The other problem is that we fail to reject the null when the null was false and we really should have failed, or we really should have rejected it. That's called a type 2 error. Okay. Our question here asks which one was worse. That really just depends on the situation. Okay? It varies from case to case and scenario to scenario, but what you need to be able to do is identify each error in a given scenario. So, if we look at this scenario, the manager of a fast food restaurant wants to reduce the proportion of drive-thru customers who have to wait more than 2 minutes to receive their food once their order is placed. Based on store records, the proportion of customers who had to wait at least 2 minutes was P equals 0.63. To reduce this proportion, the manager assigns an additional employee to assist with drive-thru orders. During the next month, the manager will collect a random sample of drive-thru times and test the following hypotheses. The null is that P is equal to 0.63, so that there's no difference between the old method and the new method. And the alternative is that P is less than 0.63, where P is the true proportion of drive-thru customers who have to wait more than 2 minutes after their order is placed to receive their food. So we're wanting to see that proportion go down. So this asks us to describe a type 1 error and a type 2 error in the setting and explain the consequences of each. So a type 1 error in this situation would be if he rejects the null when he should not have. So that means that he rejects the null and says that yes, the proportion of people who have to wait this long really has gone down, when in truth it has not. Okay? So the consequence with that would be that he's now paying this extra employee when having the extra employee really does not help at all. Okay, a type 2 error would be failing to reject when he really should have rejected. So with that error in context, the manager does not see an improvement, and so he says there is none in his test when really there was. So a consequence of this might be that he gets rid of the employee because he thinks it's not helping, even though it is, and then customers have to go back to waiting the time when really times had improved. Okay, if they were to ask you which one's worse, again, it's really just your opinion as long as you back it up. So which one is worse? Paying someone who is not really helping in your goal and then not trying any more ways to improve that, or getting rid of someone who really was helping and drivers having to go back to waiting the times they were used to waiting. Again, as long as you back it up, it is your choice as to which one is worse. Okay. Now the question is, what is the probability of a certain error happening? In this case, the probability, or in all cases, the probability of a type 1 error, since that is rejecting when we should not have rejected, is just the probability of rejecting, which in all of our cases is alpha. So if you want to reduce the probability of a type 1 error, that just means you need to reduce your alpha level. But yes, there are drawbacks. Okay? The drawbacks to this are that, one, when you reduce your alpha level, you're more likely to have a type 2 error where you fail to reject when you should not have rejected. Because reducing my alpha level means I'm not going to reject as often. When we talk about a type 2 error, we don't really talk about the probability of making a type 2 error. Instead, we talk about the power of a test. Okay, the power of a test is 1 minus the probability of committing a type 2 error. So they are complements, type 2 errors in power. And basically, it's a test against a specific alternative. So basically, how likely am I to reject the null if this one specific alternative is true? Okay, the stronger the power, the better your test. Okay, so remember also that powers are against specific alternatives. So your power is going to be different for every possible alternative. So generally for alternatives that are further away, the power is higher than for ones that are closer to the null. And that distance is called the effect size. So basically, you're not going to be asked to calculate power or the probability of type 2. You are going to want to know that they are complements, that this is the same thing as power. And there's also a diagram that you're going to want to look at on page 541. You're going to be asked to, recognize power or identify power based on a diagram like that. And what that diagram really shows is that, let's say that we have a null hypothesis, P sub 0. We're going to work with probabilities. And so I'm going to get a sampling distribution and assume that P sub 0 is the mean of my sampling distribution. Then when I go to calculate look at my values that would cause me to reject, if alpha is, say, 0.05, then these upper 5% might cause me to reject. Okay? There's going to be a boundary level here where this is some p hat, where any p hats greater than that are going to cause me to reject. So the idea behind power is, let's say that we know P sub 0 is not true. Let's say that we know it's not P sub 0, and that we know that there's some value P sub A that is true, and that P sub A is a little bit greater than P sub 0. And so P sub A here is really and truly the center of our sampling distribution. So this is the one that we're assuming is true. This is the one that actually is true. And so our thought process is here is that we look at where this boundary is on this new graph. Okay? And we see how much, what percentage of this new graph would get rejected based on the old sampling distribution. So all of this would be rejected if I was projecting based on the same value as here, when I'm assuming P sub 0. Okay? This probability right here, whatever this probability is, that's our power. Okay? That's the probability that we would reject it if this was the true value. Okay? So, the larger the power is, the better your test. Okay? This, all the non-shaded part over here, is the probability of having a type 2 error. And remember that alpha here is the probability of having a type 1 error. They all go together. Okay. So there are 4 factors that affect the power of a test. 1, sample size. The larger your sample size, the more narrow your sampling distribution, which is better for your power. Okay, number 2, effect size. Like I said, effect size is the distance between your null value and the alternative value. And the larger the effect size, usually the larger the power. Number 3, significance level. Okay, the larger your significance level, the higher your power. However, remember that the larger your significance level, the more of a probability of having a type 1 error. So you kind of have to balance that one. And 4, other sources of variability affect power. So if you did a simple random sample when a stratified one would have given you better results. Or if you, totally threw all your knowledge of sampling to the wind and did a convenience sample, in which case none of your information means squat. Or let's say if you're doing an experiment and you do a completely randomized experiment and a blocked experiment would have been better. Okay? All those sources of variability can mess with your power.